All right, welcome. Unit 7, Note 6, mutually exclusive and inclusive, mutually exclusive and inclusive events. So this could be a long video if I can't talk. But it says a bag containing 8 marbles, 12 blue, 9 yellow, and 11 green. A marble is drawn at random. Find the probability that marble drawn is either blue or green. So when I look at this, 8, 12 is 20, 9 and 11 is 20. So there's a total of 40 marbles. So that's our number, total number. What we want is either blue or green. Blue is 12, green is 11. So 12 plus 11 is 23. So you take that 23, you divide it by 40, and you get a probability that this was 0.575. Alright, why is that important? Because technically, when I added this 12 here, I did 12 plus 11. So that tells you that those are mutually exclusive. So look at this. Mutually exclusive events, events that don't affect each other. So this was the 11, or this was the 12 and the 11, so you add the 12 and 11. Because the blue and the green, it's blue marble or green marble. There's nothing in the middle. So they don't affect each other. They just want to know what is the odds of one or the other. So then you get to add. However, every once in a while there will be inclusive events. Events that do affect each other. So rolling a number less than 3 or a 1. So when I did this, I probably would have did, okay, less than a 3. So that's a 2 or a 1. So there's 2 probabilities of that. Well, the probability of the 1 or a 1 is plus 1. Well, you actually have to subtract 1 because 1 is in this group, but it was also here in this group. So we can't count the 1 twice, so that's why you got to subtract. Otherwise, you were going to end up counting 1 twice. So that's when the events do affect each other. So I got to make it clear, and I'm going to try to. So drawing a heart or a diamond from a standard deck of cards. There's 13 of these. There's 13 of these. There's no overlap there. It's either a heart or a diamond or a spade or a club. So when you do that, that's mutually exclusive. Now, drawing an ace. So there's 4 of those. Or a spade, and there's 13 spades from a standard deck of cards. Alright? This is an example of an inclusive. When you do one of these, you have looked at this, and you have counted the ace of spades. This is a spade here. You can thank me for my handiwork. You've counted this card twice. You counted it in this group of 4 and this group of 13. So you have to subtract that 1. So then you do 4 plus 13 is 17 minus the 1. That's probability is now 16 out of 52. So you have to subtract that 1 that we counted twice. And sometimes that's going to happen more than once. So rolling a 5 is a 1 in 6 chance. Alright? Or a number greater than 3. So then we write down 4, 5, and 6. So then this 5 here, if you look here, rolling the 5, and this 5 here, you're counting it twice. So you have to subtract one of those probabilities. Now, it's not always one that you subtract. Guess what? M&Ms are red or they're blue. So they are mutually exclusive. They don't have a red and blue one of M&Ms. So that's why they're mutually exclusive. There's no overlap. There's no way you can count red or blue twice. So let's look at some actual examples and find the probability. One teacher must be chosen to supervise the senior class fundraiser. There are 12 math teachers, 9 language arts teachers, 8 social studies teachers, and 10 science teachers. If the teacher is chosen at random, what is the probability that the teacher is either a language arts teacher or a social studies teacher? So when I see that, do we have teachers that teach both language arts and social studies at the same time? The answer here should be no. So they are mutually exclusive. So then we go back. Language arts teachers are 9. Social studies teachers are 8. So I would have said 9 plus 8 is equal to 17. Now the fun fact here is 12 and 9 is 21, plus another 8 is 29, plus 10 is 39. So really, the probability that a teacher is a language arts teacher is 9 out of 39, and then the probability that it's a social studies teacher is 39. But when you add fractions, you keep the 39 the same. So you are just finding the probability of 17 divided by 39. Now those are two prime, not prime numbers, but goofy ones. And I would have said this equals 0.436. Because remember, we want probabilities between 0 and 1. 1 being 100% chance, and 0 being 0%. Alright, next one. 6. Suppose that a lot of students, 1,400 students, 550 take Spanish, 700 take biology, 400 take Spanish and biology. What's the probability that a student selected at random takes Spanish or biology? So here's what we have. We have 550 take Spanish, 700 take biology. So this is an example of an inclusive one. So how I would have started it out, Spanish or biology. So how many are in Spanish? There's 550 out of 1,400. Now I need to add that to the ones that take biology, which is 700 out of 1,400. Now what happens is they tell us how many take both. So the number that take both are already being counted twice. They're being counted in this group, and they're being counted in this group. So then you have to subtract the 400 out of 1,400 that are in both. Because I'm good at math, you know you're dividing by 1,400. That stays the same. Right? 550 and 700 is 1,250 minus 400. You're going to have 850 out of 1,400. So make sure you can do that in a calculator. And when you do that, you are going to get 0.6 repeating. Alright, so make sure you're comfortable finding some of these on your own. That doesn't seem right. 850 divided by 1,450. Oops, this is, I was looking at the next answer. Hold on. This is 0.586. Alright, so make sure you're doing math on your own and trying the calculator. Alright, moving on. Next. Now, there are 1,200 subscribers to an internet service provider. Of these, 1,200 own HP, 500 own Dell, and 100 own both. So that 100 stands for the group that we're counting twice. So what I would have done is I would have looked at this and said 1,200 out of 2,400. I got to add, those are the HP computers. Now you add the 500 that own Dell out of 1,400. But we need to subtract the 100 that own both. And when you do some crazy math like this, you're going to get 1,400. Now, hint, hint, we're subtracting, so these are inclusive of each other. Now, 12 plus 5 is 1,700 minus that. This is 2,400. Sorry. So this is now 1,400 out of 24. So 1,400 divided by 2,400, you're going to get 0.5. This is 1,600. And this is 0.6 repeating because we talked about it on the last one. Okay? Sorry for my math there. Alright, so just get comfortable doing some calculations. So if they fall in both categories, they own both HP and Dell, those are always inclusive ones where you're going to be subtracting things. Your quiz question is decks of cards. Alright, so you got to be comfortable with face cards, aces, all those things. Number 8, there are 4 algebra books, 3 literature books, and 2 biology books on a shelf. If a book is randomly selected, what's the probability of selecting a literature book or an algebra book? Now, there's 4 algebra books, and there's 3 literature books. So I'm going to add those together. Now 4, 3, and 2, that means there's 9 books. Alright, now we're at 7 out of 9. Do I need to subtract any? Do you think some books have literature and algebra in them? Good guess, they don't. So this is a mutually exclusive one, and it's going to be 0.7 repeating, or 0.778 if you want to round to 3. A lot of times with probabilities, we'll round to 3 decimals if it's not a perfect one. If it's a repeating one, you can put the repeating symbol. I won't mind that at all. Looking at number 9, bingo. In the game of bingo balls are numbered 1 through 75. These numbers correspond to columns on a bingo card as shown in the table. A number is selected at random. What is the probability that it is a multiple of 4 or is in the O column? Well, first off, you got to know the multiples of 4. So I would have did 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. And I would have did 44, 48, 52, 56, 60. Now I got to keep going. So 64, 68, 72, and I'm done. Notice we stop at 75. So the first thing I would look at is there's 5, 10, 15, 18 multiples of 4 out of 75. Plus, in O, each thing has 15. So that's going to be plus 15 out of 75. Now, O is 61 through 75. So these 3 numbers right here are multiples of 4. However, those 3 numbers have been counted twice. They've been counted in this group, in this group. So we need to subtract 3 of those 75 off. So 18 plus 15 is 33. Minus 3 is going to be 30 out of 75. And 30 divided by 75 is going to equal 0.4. So that's your probability that it's a multiple of 4s in the O column. So that's a pretty good problem. First you had to know multiples of 4, or you also had to know the values in the O column, and you had to figure out that these 3 overlap. The overlapping ones is the ones you subtract, right? Because they've been counted twice. They've been counted in the 18s and the 15s. All right, moving on. A card is drawn from a standard deck of cards. Well, it's probably drawn an ace or a face card. So there's an ace card in each suit. So that's 4 cards. And remember the face cards, well, if there's 4 in another suit, and a queen in another suit, and the king in the other suit, all right, we told you face cards are 12. You should be able to see that. You know aces are 4. So either way, this is going to be 16 cards. Now, there's not some that count as aces and jacks, so it's just going to be mutually exclusive. And if I didn't circle it, you know that last problem was inclusive because we had to subtract. And you should get 0.308 when you do this math in your calculator. I was talking about this one. We didn't circle it, but this is definitely inclusive. So, moving forward, there's not Schoology quizzes at the moment. You have to know, hey, do I got to subtract a few probabilities because I counted them too many times? All right, so that's what it means when it's mutually exclusive and inclusive. Thanks for listening. Have a wonderful rest of your day.